Good morning, students. Today we will discuss some more problems based on analytic functions. Now, first question is show that the function e power x cos of y plus iota sin of y is holomorphic meaning analytic, is holomorphic and find its derivative. Now solution. Here the given function is fz equal to e power x cos y plus iota sin y, or this is equal to e power x cos y plus iota e power x into sin of y, or it is u plus iota v. Now for analytic function, first of all I will prove that the CR equations are satisfied. For that I will calculate curly u by curly x. Now here I find u is e power x cos of y and v is e power x sin of y. Now curly u over curly x, partial derivative of u with respect to x, it is e power x cos of y. Curly u by curly y, e power x as it is, partial derivative of cos y with respect to y, it is minus sin y. Curly v over curly x, sin y as it is, partial derivative of e power x with respect to x, it is e power x. Curly v over curly y, it will be e power x into cos of y. Now clearly curly u by curly x is equal to curly v over curly y. Both are equal and there is a difference of negative sign in these two values, and curly u by curly y equal to minus curly v over curly x, and hence CR equations are satisfied. Also, the first order partial derivatives of u comma v, these are the first order partial derivatives of u v. These are continuous everywhere, and therefore fz is an analytic or holomorphic function. Now I will find the value of derivative f dash z. Its formula is curly u by curly x plus iota curly v over curly x. Now curly u by curly x is e power x cos of y plus iota curly v over curly x, it is e power x sin of y. That is, result is e power x common cos y plus iota sin y equal to e power x. The formula is cos of theta plus iota sin of theta, it is e power iota theta. Therefore here I get e power iota y. Now base same, therefore powers will be get added. Now x plus iota y is z, and therefore f dash z is e power z. This is the required result. Now next one. If n is real, then show that r power n cos n theta plus iota sin n theta is analytic except possibly when r equal to 0 and that its derivative is n r power n minus 1 cos of n minus 1 theta plus iota sine of n minus 1 theta. Now solution. Here I will first of all show that the function is analytic except at r equal to 0. Now here f of z is r power n cos of n theta plus iota sine of n theta equal to r power n cos n theta plus iota r power n sin n theta, that is u plus iota v. Therefore u is r power n cos n theta and v is r power n sin n theta. And thus curly u over curly r, and it is to be noted that here the function is in polar form. Therefore I will find the partial derivatives with respect to r and theta. Now curly u by curly r, it is n r power n minus 1 cos of n theta. Curly u by curly theta, it will be minus n, its partial derivative minus n sin n theta into r power n sin n theta. Similarly curly v over curly r, it is n r power n minus 1 sin n theta, and curly v over curly theta is n r power n cos of n theta. Now it is clear that curly u by curly r equal to 1 by r curly v over curly theta. Like if you divide it by r, both of these get equal, and curly v over curly r is minus 1 by r curly u by curly theta. You have to divide curly u by curly theta by r, and both of these will get equal when one is multiplied by negative sign. And therefore these are the CR equations. Therefore CR equations are satisfied, and also the first order partial derivatives of u and v are continuous everywhere. Therefore fz is analytic. Now f dash z. Now here the formula for f dash z will be 1 over derivative of z with respect partial derivative of z with respect to r into curly w by curly r, or curly f over curly r. Better to write f. Then this is z is r cos theta plus iota r sin theta. Therefore its derivative will be 1 by and on simplification you will get here cos theta minus iota sin theta into curly f over curly r. As here z is r cos theta plus iota r sin theta. Therefore curly z by curly r, it will be cos theta plus iota sin theta, and hence 1 over curly z over curly r, it will be 1 over cos theta plus iota sin theta. Now rationalize it. You will get cos theta minus iota sin theta divided by cos theta plus iota sin theta, or it is equal to cos theta minus iota sin theta over cos square theta minus iota square sin square theta. It will give you 1. This is equal to 1, and thus 1 over curly z by 1 over partial derivative of z with respect to r is cos theta minus iota sin theta, that we have written over here. Now we have to multiply it by partial derivative of f with respect to r. Therefore it is equal to cos of theta minus iota sin of theta. F is this. Partial derivative of f with respect to r, it will be n r power n minus 1 cos n theta plus iota n r power n minus 1 sin n theta, or equal to n r power n minus 1 outside into cos theta minus iota sin theta into cos n theta plus iota sin n theta. Now multiplying, we will get n r power n minus 1 cos theta into cos n theta plus iota sin n theta into cos theta minus iota sin theta into cos n theta minus iota square, meaning plus sin theta into sin n theta, or it is equal to n r power n minus 1 cos theta cos n theta plus sin theta sin n theta plus iota into sin n theta cos theta minus sin theta cos n theta equal to n r power n minus 1. It will give you cos n minus 1 theta plus iota sin n minus 1 theta, and it exists for all values of r except when r is 0 and n is less than equal to 1. This exists for all finite values of r including 0 except when r equal to 0 and n is less than equal to 1, because when n is less than equal to 1, it will go in the denominator, and when r is 0, it will be of the form 1 over 0 power some number, which doesn't exist. Now next question. Show that if fz is analytic and real part of fz is constant, then fz is also constant. Now solution. We consider fz equal to u plus iota v. Now let fz equal to u plus iota v be an analytic function. As it is analytic function, therefore by CR equations we have curly u by curly x equal to curly v over curly y, and curly u by curly y equal to minus curly v over curly x. Now it is given that real part of f of z is constant, and thus u is constant, and therefore partial derivative of u with respect to x as well as partial derivative of u with respect to y both will be equal to 0. And by using CR equations, we get curly v over curly x equal to 0, curly v over curly y equal to 0. This implies v function of x comma y, it is also a constant, and this implies that fz equal to u plus iota v equal to c1 plus iota c2 is also constant. Next sum. Given that u equal to x square minus y square and v equal to minus y over x square plus y square, then prove that both u and v are harmonic functions, but u plus iota v is not an analytic function of z. Now first of all I will show that u and v are harmonic. Harmonic meaning both of these satisfy Laplace equation. Now u is x square minus y square, therefore curly u by curly x it is 2x, and curly to u by curly x2 is 2. Curly v over curly y it is minus 2y, and this implies, sorry, here it is u, and this implies curly to u by curly y2 it is minus 2. On adding we get curly to u by curly x2 plus curly to u by curly y2 equal to 0, and this implies u is a harmonic function. We call this 1 and 2. Now consider v. Now v equal to minus y over x square plus y square, therefore curly v over curly x equal to denominator whole square, denominator as it is partial derivative of numerator with respect to x minus numerator as it is, that is minus y as it is, partial derivative with respect to x of denominator, that is x square plus y square. From here we get x square plus y square into 0 minus minus plus its derivative 2x divided by x square plus y square whole square, and therefore curly v over curly x is 2xy divided by x square plus y square whole square. Number 3, therefore curly to v over curly x2, its partial derivative again with respect to x, it is equal to denominator whole square, that is x square plus y square power 4, denominator as it is, partial derivative with respect to x of numerator, that is 2xy, minus numerator as it is, partial derivative with respect to x of denominator, that is x square plus y square whole square, or it is equal to x square plus y square power 4, x square plus y square whole square, its partial derivative with respect to x, it will be 2y, minus 2xy as it is. For its partial derivative, first of all I will solve this whole square, 2 times x square plus y square power 1 into its partial derivative with respect to x, it will be 2x. From here we get curly 2v over curly x2 is x square plus y square common, inside I get x square plus y square into 2y minus 2xy into 4x into 1 divided by x square plus y square whole power 4. It is equal to 1 will be cancelled out. In the denominator I will get power 3. Now here 2x square y minus 2x square y minus plus 2y cube minus 2 4s are 8 x square y, or this implies that curly 2v over curly x2 is 2y cube minus 6x square y over x square plus y square whole cube. Now partial derivative of v with respect to y, it is v. Now curly v over curly y equal to, let us call this as 4, denominator whole square, denominator as it is, partial derivative of numerator with respect to y, minus numerator as it is, partial derivative with respect to y of denominator, that is x square plus y square, equal to x square plus y square into minus 1 minus minus plus y into 2y divided by x square plus y square whole square, equal to minus x square minus y square plus 2y square divided by x square plus y square whole square, or this is equal to minus x square plus y square divided by x square plus y square whole square. This is curly v over curly y. Let us call this equation as number 5. Now curly 2v over curly y2, this is equal to denominator whole square, that is power 4, denominator as it is, partial derivative with respect to y of numerator, that is minus x square plus y square minus numerator as it is into partial derivative with respect to y of denominator, that is x square plus y square whole square, or it is equal to x square plus y square whole square, its partial derivative with respect to y, 2y minus x square plus y square into 2 x square plus y square power 1 into its partial derivative with respect to y, 2y divided by x square plus y square whole power 4. That is curly 2v over curly y2 is equal to, now from here I take x square plus y square common. X square plus y square common. Inside I get 2y into x square plus y square minus, this will give you 2 to the 4y into minus x square plus y square divided by x square plus y square whole power 4, or this is equal to, this will be cancelled out. In the denominator I will get x square plus y square whole cube. In numerator 2x square y plus 2y cube minus minus plus 4x square y minus 4y cube, or this is equal to 6x square y minus 2y cube divided by x square plus y square whole cube. It is curly 2v over curly y2, and let us call this equation as equation number 6. Now we add equation 4 and 6. In equation 4, curly 2v over curly x2, it is 2y cube minus 6x square y over x square plus y square whole cube. And in this equation, curly 2v over curly y2 is just negative of 4th. Adding 4 and 6, we get curly 2v over curly x2 plus curly 2v over curly y2 equal to 0. Therefore, v is a harmonic function. V is a harmonic function. Now further we have found that curly u over curly x is 2x, curly u over curly y is minus 2y, curly v over curly x is 2xy over x square plus y square whole square, and curly v over curly y, it is minus x square plus y square divided by x square plus y square whole square. And therefore curly u by curly x is not equal to curly v over curly y, and curly u by curly y is not equal to minus curly v over curly x. Therefore CR equations are not satisfied, and therefore the function u plus iota v is not analytic, and therefore u plus iota v is not an analytic function, is not an analytic function of z. Now next sum. Next question. If phi and psi are functions of x and y satisfying Laplace equation, then show that s plus iota t is analytic, where s equal to curly phi over curly y minus curly psi over curly x, and t is curly phi over curly x plus curly psi over curly y. Now proof. It is given that phi and psi are functions of x and y satisfying Laplace equation, as phi and psi are functions of x and y satisfying, or functions of x and y satisfying the Laplace equation therefore curly 2 phi over curly x2 plus curly 2 phi over curly y2 equal to 0 and curly 2 psi over curly x2 plus curly 2 psi over curly y2 is 0. Now we have to show that to prove s plus iota t is an analytic function. For this we will have to show that both of s and t satisfy CR equations. That is to prove curly s over curly x equal to curly t over curly y and curly s over curly y equal to minus curly t over curly x. Just in this case I have s in place of u and t in place of v. Now curly s over curly x, it is curly x of, I substitute the value of s, curly phi over curly y minus curly psi over curly x. Therefore I get it is equal to curly 2 phi over curly x curly y minus curly 2 psi over curly x2. Now curly t over, I will first of all show this, curly t over curly y equal to curly y of, substitute the value of t, curly phi over curly x plus curly psi over curly y equal to curly 2 phi over curly y curly x minus curly 2 psi of curly y2 plus. Now I subtract, let us call this 3 and 4. Now 4 minus 3, this implies curly t over curly y minus curly s over curly x equal to curly 2 phi over curly y curly x plus curly 2 psi over curly y2 minus curly 2 phi over curly x curly y minus curly 2 psi over curly x2. This is equal to curly 2 phi over curly y curly x plus curly 2 psi over curly y2 minus curly 2 phi over curly x curly y minus plus curly 2 psi over curly x2. Or this is equal, these are equal, this is cancelled out, curly 2 psi over curly y2 plus curly 2 psi over curly x2, and this is equal to 0 using 2, and thus I get, and therefore curly t over curly y equal minus curly s over curly x equal to 0. This implies curly s over curly x equal to curly t over curly y. Therefore I have proved this equation. Now for this consider I just consider this equation, curly s over curly y plus curly t over curly x. This is equal to curly y of, I substitute value of s. S is curly phi over curly y minus curly psi over curly x plus curly x of, now value of t, curly phi over curly x plus curly psi over curly y. This is equal to curly 2 phi over curly y2 minus curly 2 psi over curly y curly x plus curly 2 phi over curly x2 plus curly 2 psi over curly x curly y. These are cancelled out. This becomes equal to curly 2 phi over curly y2 plus curly 2 phi over curly x2. This is again equal to 0 by using 1. Therefore I get I get curly s over curly y plus curly t over curly y, I get curly s over curly y plus curly t over curly x equal to 0. This implies curly s over curly y equal to minus curly t over curly x. Therefore, s plus iota t is an analytic function, and hence the result.